Hello guys, welcome to the DMS online school. If you are new to this channel, you are most welcome. And on this channel I teach mathematics, biology, science, and also revise past examination question papers. Alright, so today's lesson will be looking at the preparation of salts, and it doesn't matter the country you come from, whether you come from UK, you come from USA, Canada, German, Australia, Netherlands, it doesn't matter. The lesson that I'm going to teach on preparation of sauce actually is universally the same. All right, so if you are new to this channel and you haven't subscribed, please consider subscribing and liking the video. All right, so we are going to do a quick revision of what we did. All right, so if you remember in the previous video, if you never watched it, the link is here, you can click and watch. In the previous video we looked at the preparation of salts, and we ended on the methods for preparing salts. All right, we said there are basically 4 methods of preparing salts, and we said number 1, titration or neutralization method. We also said number 2, displacement method or filter and crystallization method. Then number 3 we said precipitation or double decomposition method, and then number 4 we said direct synthesis method. All right, so let's look at now the solubility rules. All right, because we said these methods mentioned here of preparing salts depends on the solubility of the salt and the nature of reactants. So we said solubility is the measure of the extent to which a substance dissolves in water. Then we said substances that have high extent to dissolve in water are said to be soluble, while those that have a lower extent to dissolve in water are said to be insoluble ones. All right, so before we go deep into the lesson, something important to remember is that 1, salts contain a metal and a non-metal or radical. So in the formula of a salt or the salt itself, for example, potassium chloride. So potassium is a metal, then chloride is a non-metal. Then if we say potassium sulfate, potassium is a metal while sulfate is a radical. So this is what you should remember. A salt must consist of a metal and a non-metal or a radical. All right, so now let us look at the solubility rules. All right, so we'll start with the salts of potassium, because when we talk of solubility rules, they're actually important, because after understanding what solubility rules are, then it will be very easy for us to know how to prepare salts and which method we should use to prepare a particular salt. All right, so these solubility rules must be memorized and be remembered at all times when dealing with the questions to do with preparation of salts. All right, so let's start with the salts of potassium. So we say all sorts of potassiums or all sorts of potassium are soluble. So all sorts of potassium are soluble. It can be potassium nitrate, potassium chloride, potassium sulfate, potassium carbonate. All these sorts of carbonate, of potassium, are all soluble. So there's no sort of potassium salt is insoluble. All right, so let's move to sorts of ammonium. So equally here we say all sorts of ammonium are soluble. So we can have ammonium nitrate, ammonium sulfate, ammonium carbonate, ammonium chloride. So all these salts that I've mentioned are soluble. So we don't have any salt involving ammonium that we know to be insoluble. All right, so let's move to salts of sodium. So all sorts of sodium are soluble as well. So all sorts of sodium are soluble. All right, so we don't know any sort of sodium that is insoluble. All right, so let's move to sorts of nitrate. So equally here, all sorts of nitrate are soluble. So all sorts of nitrate are soluble. We don't know any sort of nitrate that is insoluble. So, for example, sodium nitrate is a soluble salt. Potassium nitrate is a soluble salt. Zinc nitrate is a soluble salt. Silver nitrate is a soluble salt. So, all salts involving nitrate are all soluble. All right, so these are solubility rules that you should know. And to help us to remember this, there's this short way of remembering all these that I've mentioned here. So P here stands for potassium. So this word, the pansoni, you know, in Bemba, pansoni, it can help you to remember P for potassium salts, then A for ammonium salts, then SCO for sodium salts, then Ni for nitrate. So for you to know which salts are soluble, you just have to use this word, the pansoni. Then you just know potassium salts are soluble, then this one, ammonium salts are soluble, sodium salts are soluble, nitrate salts are soluble. So this is what we do for us to be able to remember. Even teachers, even those learners that do well in the exam, they come up with a system that helps them to remember whatever it is that they're trying to remember. All right, so let's look at sorts of chloride. Right, so we say that all sorts of chloride are soluble except the sour chlor, ones. So we are saying all sorts of chloride are soluble except the sour chlor ones. So what do I mean by the sour chlor ones here? So in these sour chlor ones here, we mean the Si, this Si here for silver, and this Le here for, which is Le here for lead, and this chlor here, which is chlor for chloride. All right, so this means this means silver chloride and lead chloride are insoluble. So what it means here, this is also a short way of memorizing the sorts of chlorides that are insoluble. We are saying all sorts of chloride are soluble except sour chlor. So meaning in the sour chlor, we have hidden sorts of chloride that are insoluble. So which sorts? This Si stands for silver and Le stands for lead. So in short, what we mean here, we are saying silver chloride is insoluble and also lead chloride is also insoluble. So these we must memorize. That's what we mean here. All right, so other sorts of chloride are soluble, but only these are insoluble. So it's important to memorize these sorts. All right, the rest we don't care because it will be known that they are soluble. All right, so let's move to sorts of carbonates. All right, so we say all are insoluble except the sorts of ammonium, sodium, and the potassium. All right, so this is easy to remember. All right, so we are saying sorts of carbonate, all sorts of carbonate are soluble. I mean insoluble, except the sorts of ammonium, sodium, and the potassium. So if I have ammonium carbonate, it is a soluble salt. Sodium carbonate, it's a soluble salt. Potassium carbonate, it is a soluble salt. But if I say zinc carbonate, it is an insoluble salt. Copper 2 carbonate, it is an insoluble salt. Calcium carbonate, it is an insoluble salt. Zinc carbonate, it is an insoluble salt, because the ones we have mentioned to be soluble are these ones here. The rest are insoluble. All right, I hope you are getting something. So let's move to sorts of sulfate. So we are saying all sorts of sulfate are soluble except the carbonyl SAW ones. So now, what have I hidden in this word Kabale SAW? So we are saying the Ka, which is a Ca, stands for calcium. The Ba, which is this one, stands for barium. And the SAW, which is this one, stands for sulfate. So in this word, we have hidden the Kabale SAW, which means that calcium sulfate and barium sulfate and lead sulfate are insoluble. All right? So all sorts of sulfate are soluble except the Kabale SAW ones. So in this way, we have hidden calcium, barium, lead, then this is sulfate. So if I have calcium sulfate, it is insoluble. Barium sulfate, insoluble. Lead sulfate, insoluble. So the other salts are soluble. I can have sodium sulfate, potassium sulfate, zinc sulfate, copper 2 sulfate, silver 2 sulfate. All those are what? I mean silver sulfate. All those are soluble salts. But these ones are insoluble. All right? I hope you are getting this clearly. Now, let's move to sorts of bases, or sorts that are formed from bases. All right? So these ones we are saying sorts of bases, or oxides and the hydroxide. So we are saying all are insoluble except the salts of ammonium, sodium, and the potassium. All right? So the salts that can be made of hydroxide, the ones that can be soluble are like ammonium hydroxide is likely to give a soluble salt. Sodium hydroxide is likely to give a soluble salt. Then potassium hydroxide is likely also to give a soluble salt. Equally, ammonium oxide, sodium oxide, potassium oxide, they are likely to give you a soluble salt. But the rest won't give you a soluble salt. All right? So now, after looking at the solubility rules here, all right? So after looking at the solubility rules, let's look at these. So we are saying hydroxides and oxides of magnesium and calcium are slightly what? Soluble. So these ones are considered to be slightly soluble. So hydroxides and oxides of magnesium and calcium are slightly soluble. So if they are slightly soluble, then definitely they are not soluble. All right. So now let's look at the methods of preparing salts, or of salts preparation. All right. So we have come back now. Methods of preparing salts. We said 1, titration or neutralization method. So this titration or neutralization method, what kind of salts is it used to prepare? So we say this method is used to prepare soluble salts of group 1 metals, e.g. potassium salts, sodium salts. You see, so titration can be used to prepare salts of group 1 metals such as potassium salts, sodium salts, etc. So this is how this method is used. Soluble salts and of group 1 metals. All right, and also ammonium here. All right, so including ammonium. So this is what I said. I said it is used also to prepare salts of ammonium, this titration. So you bear in mind, you memorize, and remember always that neutralization or titration is used to prepare salts of group 1 such as potassium, sodium, etc., and also ammonium salts. All right. So now, when you are using this method to prepare a salt, reactants should be in what form? So we are saying this method involves reacting a suitable base with a suitable acid. So meaning that if you are asked to prepare a certain salt, then the reactant that must be used to prepare such a particular salt must be a suitable base and a suitable acid. So that's how this method works. A base and an acid. And you'll see what we mean by suitable base, suitable acid later when we start looking at the actual process of preparing salt. All right. So let's move and look at another method, which is the displacement method or filter and crystallization method. So this method is used to prepare soluble salts of group 2 metals and transition metals. So you hear this method is used to prepare what? Soluble salts of group 2 metals and transition metals. So if you have a salt of group 2 like magnesium sulfate, then you know that this is a salt of a group 2 metal because magnesium is in group 2. And definitely when preparing this salt magnesium sulfate, which is a soluble salt, the method that you should use is the displacement method or filter and crystallization method. All right? I hope you are getting sense in this. Also, when we talk of transition metals like zinc, I can talk of zinc nitrate. Zinc nitrate is a salt. So zinc is a transition metal. So since zinc is a transition metal, so the method that I should use is displacement method of filter and crystallization because zinc nitrate is also a soluble salt. All right, so we are saying it involves one, reacting a suitable dilute acid with a suitable mazit metal, e.g. used to make a sort of mazit metals. So what we are trying to say here is that when you are preparing a salt using displacement method or filter and crystallization method, what you should bear in mind is that the reactants that must be used to prepare such a particular salt you are being asked or you are asked to prepare, the reactants must be a suitable dilute acid and a suitable actual metal. All right. Then secondly, we are saying reacting a suitable dilute acid with a suitable insoluble carbonate. So depending on what salt you are being asked, so you can either use the dilute acid and the actual metal, or you get dilute acid and the metal carbonate, insoluble carbonate containing that particular metal. All right, so you will see as we continue learning. So let's now look at number 3, reacting a suitable dilute acid with a suitable insoluble base. So you see here there are 3. Either you react a suitable dilute acid with a suitable insoluble base. All right, so let's look at the last method here, which is precipitation or double decomposition. So this method is used to prepare insoluble salts. Now you see one method has come out, so easy to remember. So one method has come out, which is precipitation or double decomposition method, as a method used to prepare insoluble salts. So the one we talked about, titration or neutralization, then displacement or filter and crystallization. These are used to prepare soluble salts of different characteristics. But this precipitation method is used to prepare insoluble salts. You see? So easy to remember how these methods work. All right? So now, it involves reacting to suitable soluble salts. So if you want to prepare a particular insoluble salt using precipitation method, then the reactants that must be combined to form that salt being asked to prepare, those two reactants, or those reactants must be two soluble salts. You need two soluble salts that must be reacted together to give that particular insoluble salt that you need. All right. So the last method is a direct synthesis method. Although this one I will not talk about it more, but just know that it exists, and this method is used to prepare soluble salts of maziti metals. So direct. For example, if we are preparing magnesium chloride, we can get magnesium metal and react it directly with chlorine to form magnesium chloride. That's what we mean by direct synthesis. All right. So now, so I've already explained it. All right. So now let's look at this example here. So this example is saying, name the nature of the salt, method of preparation, and suitable reagents for preparing the salt. So we have A, potassium nitrate, zinc sulfate, silver nitrate, and sodium nitrate. So these salts, of all the salts here, they are asking us to state the nature of the salt, the method of preparing the salt, and also the suitable reagents for preparing the salt. So, for example, they need us to mention the method of preparing potassium chloride, the method of preparing zinc sulfate, the method of preparing silver chloride, the method of preparing sodium nitrate. All right, so something to remember here. All right, we are saying salts contain a metal and a non-metal or radical. I also said this. So for example, we have potassium chloride, potassium a metal, then chloride or a non-metal from chlorine. All right. So now let us look at the potassium, or let's remember the methods of preparing salts. All right. So let's recall the methods of preparing salts, because this salt here is potassium chloride, so it contains potassium here. What did we say? We said salts of potassium are what? All salts of potassium are soluble. That's what we said. And remember, we said also about the method. All right. So we said titration or neutralization method. So we said this method is used to prepare soluble salts of group 1 metals, e.g. potassium salts, sodium salts, etc. So look at this. So if they say we mention number 1 here, if they say we mention what? The nature of the salt. So the nature of the salt, we want to mention whether it is soluble or insoluble. So here we said what? We said all sorts of potassium are soluble. So this salt, potassium chloride, hence will be soluble. Then method, all right? So I said titration method here, I said is used to prepare salts of what? Group 1 metals, e.g. potassium salts, sodium salts. So in this case, the method for preparing potassium chloride will be titration or neutralization method. All right. So so we are saying this. We said this involves reacting a suitable base with a suitable acid. So now, for you to prepare potassium chloride, you need suitable reagents, suitable base, and a suitable acid. All right. So see, they are saying suitable reagents for preparing that. All right. So let's now answer this one. So potassium chloride here. So we are going to say the nature of the acid is, salt is soluble. Then secondly, we are going to say method of preparation is titration or neutralization. Then thirdly, suitable reagents are potassium hydroxide. So you see, suitable. So now when we say suitable, make sure the reagents that you must choose, one of it must contain the potassium, then the other must contain the chloride. So remember, potassium chloride must be prepared from a suitable base and a suitable acid. So when you hear chloride, so it is coming from a suitable base known as, suitable acid known as hydrochloric acid. Then potassium should come from a suitable base, which contains potassium itself, which is potassium hydroxide. So these two, when they react, now they will form potassium chloride. This potassium and hydrochloric acid, that chlorine, will give potassium chloride. All right. So let's move to now look at zinc sulfate. So what did we say about sulfates? So we said all sorts of sulfate are soluble except the Cabale-Sau ones. So the Cabale-Sau ones are insoluble, but the rest are soluble. So these Cabale one, we said Ca for calcium, Ba for barium, then Le for lead, and Sau for sulfate. That's what we said. And we also said that this means calcium sulfate, barium sulfate, and lead sulfate are insoluble salts. All right. So now, when you check zinc sulfate in terms of solubility, is it soluble or insoluble? So the answer is it is soluble because it is not among the calcium sulfate, barium sulfate, and lead sulfate. It's not. So these are the only ones that are insoluble. So zinc sulfate will be soluble. All right. Then the method for preparing zinc sulfate, since zinc sulfate is a sort of a transition metal, so the method must be what? Displacement method or filter and crystallization, because we said this method is used to prepare soluble salts of group 2 metals and transition metal. So this zinc is a transition metal. So zinc sulfate is a sort of a transition metal. So, and since zinc sulfate is also soluble, then it will be prepared by displacement method or filter and crystallization method. All right. Now, let's move to what it involves. So we said it involves what? Reacting a suitable dilute acid with a suitable mazite metal. All right. So we are saying zinc sulfate can be prepared by displacement method or filter and crystallization method. All right. So we are saying this method is used to prepare soluble salts of group 2 metals and transition metals. So this zinc sulfate is a sort of a transition metal, which is zinc. All right. And in this method, it involves reacting a suitable dilute acid with a suitable mazite metal, e.g. used to make a sort of mazite metal. So that's what we said. So mazite metal, and I didn't explain, I think mazite stands for magnesium, aluminium, zinc, iron, and tin. All right. So this zinc here is for what? Zinc here. All right. So which means that this zinc sulfate, since it is a soluble salt, then it can be prepared by what? Displacement method. All right. So let us look at the actual salts that can be, or the actual reactants that can be used to prepare zinc sulfate. All right, so here we are saying now zinc sulfate, nature of the salt, soluble. Then we are saying method of preparation, displacement of filter and crystallization method. Then suitable reagents. Then we are saying zinc metal or zinc metal itself. So zinc metal itself and sulfuric acid or zinc oxide and sulfuric acid or zinc carbonate with sulfuric acid. So remember what I said on filter and crystallization method. So filter and crystallization method has got three options. Either you react a dilute acid with a metal, or a dilute acid with an insoluble carbonate, or dilute acid with an insoluble base. In this case, it can either be a zinc oxide, an oxide or hydroxide. All right, so now in this case, now if we go and look at the reagents, or if we talk of the actual reagents that we can use to prepare zinc sulfate, the suitable reagents that can be used to prepare zinc sulfate are zinc metal. So zinc metal will provide the zinc. Then the suitable acid is sulfuric acid. So sulfuric acid will provide the sulfate here. So sulfuric acid will provide the sulfate, and then zinc here will be provided by the zinc metal. Or here we have said the zinc oxide. So in this zinc oxide, zinc will be provided there, and sulfuric acid which will provide the sulfate. All right, or zinc carbonate. So in this zinc carbonate, it can provide the zinc, then the sulfuric acid can provide the sulfate. So notice the other reactant is almost the same: sulfuric acid, sulfuric acid, sulfuric acid. Then the other reagent is now different, either zinc metal or zinc oxide. It could be zinc hydroxide as well, or zinc carbonate. All right, so let's move to another. Let's look at the sorts of chloride, because we'll look at now how we can prepare silver chloride, whether it is soluble or not, the method, and also the reagents. All right, so let's look at the sorts of chloride. Remember, sorts of chloride, we said all sorts of chloride are what? Are soluble except the sour chlor. We said the sour chlors are what? Insoluble ones. So here we said Ci or Ci for silver, Li or Le for lead, and chlor for chloride. All right, chloride. So this means that silver chloride and lead chloride are insoluble. So now when we check here, silver chloride, is it among these? Silver chloride, yes. So since it is among these, then it is an insoluble salt. And remember the one method we mentioned for preparing insoluble salts. It was what? It was precipitation or double decomposition. All right. So now here, what we are going to say here is that we'll look at now the method precipitation or double decomposition. Remember, we said this method is used to prepare insoluble salts, and we said it involves reacting to suitable soluble salts. All right, so now we are now going to answer this. So we are going to say silver chloride, nature of the salt, insoluble. Then method of preparation, double decomposition or precipitation. Now let's look at the suitable reagents. So the suitable reagents are, we need 2 soluble salts to give silver chloride. So one salt that must be chosen must contain the silver. Another salt that must be also chosen must contain the chloride. So one salt must provide the silver, another salt must provide the chloride. but these two salts must be both soluble. So I decided to bring sodium chloride. Sodium chloride is a soluble salt because we said salts of sodium are all soluble. Now, what will this sodium chloride provide? The chloride, this one. Then another salt I decided to bring is silver nitrate. So silver nitrate is a soluble salt. Remember we said all nitrate salts are soluble. Pansoni, ni, nitrate. All nitrate salts are soluble. So this nitrate salt will provide what? The silver. This other one here. So I said, or we can have also potassium chloride. So potassium chloride can provide the what? The chloride here. And what? Silver sulfate. So the silver sulfate can provide this silver here. So when we react this and this, it will give silver chloride and the sodium nitrate. But what we are interested in is silver chloride that will be provided or made. Alright, I hope you are understanding. If you are getting value in this video, please give it a like and also let me know in the comment section. Alright, so let's move to this example. So I've left out this sodium nitrate because sodium nitrate and sodium nitrate and potassium chloride use the same method because they are the salts of group 1 metals. Alright, so let's move to these examples here again. So here they are saying describe how to prepare potassium chloride. Now we have come to the main point or to the main objective of this lesson. Now we are going to look at how to prepare potassium chloride. So now remember they are saying describe how to prepare potassium chloride. So in your description, you must 1 state whether this potassium chloride is a soluble salt, then 2 the method that it is used to prepare, then 3 the reagents, then 4 the process itself of preparing this salt, how it is carried out. You must describe all that. So now let me answer this one for you. So potassium chloride, I must remember, is it a soluble salt or not? Remember, all sorts of potassium are soluble, so this salt will be soluble. So potassium chloride is a soluble salt of group 1 metal. So remember now the method of preparation. So since it is a soluble salt of group 1 metal, we said salts of group 1 metal are prepared by what method? Titration or neutralization method. Alright, so we are going to say it can be prepared by titration method or neutralization method. Then the third part now, it is to now mention the reactants that must be combined to form potassium chloride. Remember we said these 2 reactants must be suitable one, ensuring that one of the reactants must provide the potassium, then the other of the reactant must provide the chloride, and these 2 reactants, one must be the base, the other one must be the acid. So which base must provide the potassium? Potassium hydroxide. Then which acid must provide the chloride? Hydrochloric acid. So those are the suitable reagents. So we are saying the suitable reagents are potassium hydroxide and hydrochloric acid. Now procedure. How will this method be carried out in order to provide the potassium chloride? So here we are going to say procedure. So in the procedure here, mix equivalent amount of potassium hydroxide and hydrochloric acid using titration process. So here we use titration process when preparing potassium chloride. So in titration, equivalent amount of the potassium hydroxide must react with the equivalent amount of hydrochloric acid. So equivalent amounts are needed for neutralization to take place. So these salts, remember, in the properties of acids. We said acids react with the bases to form salt and water. So such a reaction is a neutralization reaction because it leads to the formation of water, which is a neutral substance. So for this base here and acid to neutralize each other to form water, unless equal amounts are combined, right? So I've put it in a short way for you to understand, even to repeat the same process in the exam, right? So we are going to say mix equivalent amount of potassium hydroxide and hydrochloric acid using titration process. So equivalent amounts are needed for neutralization process, right? So secondly, now after you react sodium hydroxide with hydrochloric acid, they form potassium chloride and water. Now if you want to remain with the water, you must evaporate the salt, you must evaporate the water. So we are saying evaporate to saturation point the resulting solution in an evaporating dish and allow the solution to cool naturally. So since this hydrochloric acid will react with the potassium hydroxide to form potassium chloride and water, but it will be in the same container. So if you want to remain now with the potassium chloride, you must evaporate to saturation point. So what is saturation point? Saturation point will be a point when you start evaporating, then you reach a point where the salts of potassium chloride will start to appear. So the moment that point is reached, you stop evaporating because you have now reached what we call saturation point. All right, so when you reach there, we are saying and allow the solution to cool naturally. Now you allow that resulting solution to cool naturally. Why do we do this? We are saying this allows a small amount of water remain to allow crystals of the salt to form. So these answers I'm putting here are actually, these points I'm putting here are actually exam answers. All right, they can ask you, why do you heat to saturation point? So this allows small amount of water remain to allow crystals of the salt to form. All right, so the way salts form, they need some water we call water of crystallization for those salt crystals to form. A crystal is a solid with well-defined shape or with straight edges. That's how it is. A crystal is like the way sugar particles appear. You see, if you can look at a sugar particle where you are, you check, you see that it has straight edges. So that particle, we can call it a sugar crystal. And for that particle to be formed, meaning in the process of sugar formation, they left some water that allowed those crystals to form, those edges to form. And that water which they allowed is called water of crystallization. So if you want crystals of a salt to be formed in this situation, you just heat the solution to saturation point and then allow it to cool naturally. So it will evaporate naturally, and that water which will remain now will help crystals to be formed, and these crystals will have straight edges. All right, so we are saying the small amount of water that remains is called water of crystallization. So now these are the two procedures. Now after you describe these procedures, now you write the equation y of potassium hydroxide, which is aqueous, potassium hydroxide aqueous plus hydrochloric acid also, which is in aqueous. All right, so this will give you this potassium will react with this chloride to form potassium chloride aqueous. Then this one hydrogen will react with the hydroxide here to form water liquid. So this reaction or this equation is balanced. All right, if you have found value in this video, guys, please let me know in the comment section. All right, you are my family. Whatever that it is that you want to know about this video. If you are not getting anything, let me know. If you are getting something, let me know, all right, in the comment section. And also give this video a like, all right, because this is the video you were waiting for, and here it is, all right. So if you downloaded this video, you didn't comment and like, please go back to the video and like and also comment. I will appreciate that. I like to respond to each and every comment of you, my viewers and subscribers. All right, so let's go to another example here, which is saying describe how to prepare zinc sulfate. All right, so again, when you look at zinc sulfate here, zinc sulfate, is it a soluble salt or an insoluble salt? That one you should know. So you must know that the sulfate only the bale saw. So the bale saw are calcium sulfate, then a barium sulfate, then lead sulfate. These are the ones that are insoluble for the sulfate. The rest are soluble. So zinc sulfate, excuse me. So zinc sulfate is a soluble salt. So since it is a soluble salt, then it can't be prepared by precipitation. And this zinc here is a metal of a transition metal. So it will be prepared by filter and crystallization method or displacement method. All right. So what we are saying is that zinc sulfate here is a soluble salt of what? Of mazite metals. All right. So we are saying it can be prepared by displacement method or filter and crystallization method. Then 3, now we look at the suitable reagents. So we are saying the suitable reagents are zinc metal and sulfuric acid. So we have decided to just pick the zinc metal and the sulfuric acid. These are the suitable reactants or reagents. Then the procedure of how these two can be mixed in order to form the zinc sulfate. So we are saying the procedure here, we are saying add excess zinc metal to sulfuric acid. Filter the excess zinc metal. Here, bubbles of hydrogen gas are produced. Excess metal is used for complete neutralization of the acid. So in this process, the way I've described it, that's how you should describe as well. So we are saying add excess zinc metal to sulfuric acid. So maybe sulfuric acid is in a beaker, then you get enough of zinc sulfate, you add to that beaker. Why do we add? We are saying excess metal is used for complete neutralization of the acid. So that zinc metal goes there to completely neutralize the acid to form the salt, because the salt that must be formed must not be an acidic salt. Then we say here there's a filter the excess zinc metal. So the excess zinc metal is filtered. It is the zinc metal that has not yet reacted. Then I said here bubbles of hydrogen gas are produced. So in this reaction, bubbles of hydrogen gas are produced. So because in the exam they can ask you to say when or during the preparation of zinc sulfate, when zinc metal was added, when excess zinc metal was added to a dilute sulfuric acid. Here it was supposed to be dilute, guys, sorry. So they'll say when excess zinc metal was added to dilute sulfuric acid, the bubbles of a gas were seen. Name the gas that was produced. That's how they trick you. So the gas is already mentioned, hydrogen gas. Then they may ask you, why was the excess zinc metal used? So you are saying excess zinc metal is used for complete neutralization of the acid. So I hope you are getting value in this video. All right. Then we are saying next is evaporate to saturation point the resulting solution in an evaporating dish and allow the solution to cool naturally. So this is basically the same as what we did. So after you filter off the excess, that resulting solution, which is now zinc sulfate, because the gas bubbles off. So you have zinc sulfate and you have already removed the excess zinc metal. So that zinc sulfate solution now, for you to remain now with the zinc sulfate, now you need to do what? Now you need to evaporate. You need to evaporate. I mean, you need to evaporate any solution or whatever it is. So we are saying evaporate to saturation point the resulting solution in an evaporating dish and allow the solution to cool naturally. This allows a small amount of water remain to allow crystals of the salt to form. The small amount of water that remains is called water of crystallization. All right, so that is what also happens in here, because this zinc now sulfate now, even if it will be like zinc sulfate, it still will be in form of liquid, so it has now to be evaporated. All right, so now the equation now will be zinc as a metal plus sulfuric acid as aqueous, which will give us a zinc sulfate aqueous plus then hydrogen gas. So this is the equation. So the equation is balanced as well. So this is the salt itself, zinc sulfate. So let's look at another example here where they are saying describe how to prepare silver chloride. All right, so now silver chloride, remember when we talked of chloride salts, we said chloride salts, all chloride salts are soluble except the sour chlor, where we said these are silver chloride and lead chloride. All right, so those are the ones that are insoluble: silver chloride, lead chloride. And definitely here we are told describe how to prepare silver chloride. Definitely silver chloride is among the sour chlor, so it is insoluble. So this salt is insoluble. Silver chloride is an insoluble salt. Then now we'll come to the method of preparation, you see. So insoluble salt, they are prepared by double decomposition or precipitation. So it can be prepared by precipitation or double decomposition. This is the method for preparing insoluble salt. Now let's look at the suitable reactants or reagents that can be or that are needed to form silver chloride. So we are saying the suitable reagents are silver nitrate and the sodium chloride. So silver nitrate will provide the silver here, then sodium chloride will provide the chloride here. All right, so now let's now describe how this method is carried out. So procedure. So we are saying mix the two reagents or mix the two salts and filtrate the resulting mixture to collect the insoluble salt on the filter paper. So now these two, when they react, this and this one, they will exchange. This will pick on the chloride. So silver will pick on the chloride to form silver chloride. Then the sodium will pick on the nitrate to form sodium nitrate. So this silver chloride that will be formed, it will be insoluble and it is called a precipitate, an insoluble substance, a precipitate. So it will be insoluble, but this sodium chloride will be soluble. So when you get these two, you mix in the same beaker. So in the same beaker, there will be silver chloride that will appear as a solid, a precipitate. But this one, sodium nitrate, will not appear. It will form, but because it is soluble, so it won't be seen. All right. So now that is insoluble, that will be formed insoluble salt silver chloride. For you to collect it, you must filter. So they are saying mix the two salts and filtrate the resulting mixture to collect the insoluble salt on the filter paper. So the insoluble salt silver chloride remains on the filter paper. So when it remains on the filter paper, then it is your salt. Then wash the precipitate, the same insoluble salt we are calling a precipitate. So wash the precipitate with distilled water to remove any soluble salt on it. So any soluble salt like the sodium nitrate that may cling to the surface must be washed out by distilled water. All right. Then the next step now, dry the precipitate to get rid of the water. So you dry now that precipitate that you have washed with water. So you dry it so that the water is removed. All right. So that's what happens. So you remain with your salt now. Now let's write the equation for the reaction. So the equation for reaction is silver nitrate, like this one. Silver nitrate is soluble plus, so it will be aqueous, plus sodium chloride. Sodium chloride is soluble, so it will be aqueous. So this will form, so this one will react with the chloride to form silver chloride. It will be solid. The precipitate is an insoluble substance, so it will be solid. Then plus, then this one and this one, they will react to form sodium nitrate. It will be aqueous. All right, so this is an equation and it appears to be balanced. All right, let me know if you are getting value in this video in the comment section. All right, so let's move to another example. I think this is the last example, which says describe how to prepare copper 2 sulfate. So now they're asking us to prepare copper 2 sulfate. All right, so copper 2 sulfate, is it a soluble salt or an insoluble salt? This one, it is a soluble salt because sulfate, only the carbonyl, calcium sulfate, then carbonyl, then barium sulfate is insoluble also. Then carbonyl lead sulfate is insoluble, but calcium, copper 2 sulfate is not insoluble. So it is soluble. So we are going to say copper 2 sulfate is a soluble salt. Now, this copper is a transition metal. So since it is a transition metal, it is not of group 1. Then we will not use titration. We will use displacement or filter and crystallization. All right. So now, the method will be a displacement or filter and crystallization. Then the suitable reagents will be these: copper 2 carbonate and sulfuric acid. Of course, I could have said copper 2 oxide or copper hydroxide. That one also would have worked. Copper 2 hydroxide, copper 1 oxide, I think, yeah, then copper 2 oxide. Because remember, under displacement method, if you go back, we said 3 ways are available for preparing a salt: either the metal itself and the acid, or the metal or the acid and the insoluble carbonate, or the acid and the insoluble base. That's what we said under precipitation, or displacement. So copper 2 sulfate here now can be prepared by displacement, and the suitable reagents can be copper 2 carbonate. We cannot pick copper metal directly because copper metal does not react with acids. So if you get a copper metal direct, you react it with sulfuric acid, nothing will happen. The salt won't be formed. That's why you should get at least a copper 2 carbonate to get the sulfuric acid. No wonder those options were provided under this method. Or you get the copper 2 oxide or the copper 2 hydroxide. All right, I hope you are getting something here. So easy, guys. So let's talk about the procedure. So under the procedure, we'll say add excess copper to carbonate to sulfuric acid, filter the excess copper to carbonate. Here bubbles of carbon dioxide gas are produced. Excess metal is used for complete neutralization of the acid. Sorry, here it should have been excess copper to carbonate is used for complete neutralization of the acid. All right, so now from here now we are saying carbon dioxide will be formed in this case. Now don't memorize the hydrogen, now it's the carbon dioxide. All right, then next what you do now is to do what? Evaporate to saturation point the resulting solution on an evaporating dish and allow the solution to cool naturally. So this allows small amount of water to remain to allow crystals of the salt to form. So just like previously what we did on another method of preparing, or on the same displacement method where we were looking at preparation of zinc sulfate. So that's why we call it displacement method or filter and crystallization, because there's a filtering involved here and also there's a crystallization, which is this process you heat to saturation point and then you allow the solution to cool naturally to allow crystals to form. All right, then now the equation will be this one, copper to carbonate here, copper to carbonate, which is being reacted to sulfuric acid, so it will be solid. So copper to carbonate here, it will be solid, plus the sulfuric acid will be aqueous. And I forgot to add also dilute. So where guys have put just sulfuric acid directly in front, you should put dilute, because we don't use concentrated acid. The reaction is just vigorous and dangerous. All right, so here say now it will react, so it will form this one now will react with this copper to sulfate aqueous, plus now there will be carbon dioxide gas plus water. All right, so this is the equation, guys. So guys, we have come to the end of this lesson. I hope you enjoyed this lesson, and if you enjoyed, let me know in the comment section. And please, this is a special announcement. I'll be having tuitions during the holiday and I'll be talking about major topics, guys, that are always present in the examination. So don't miss only 60 kwacha, guys. Remember the 60 kwacha, if you don't pay me and you have it, you stingy yourself. You know, you can, how long can it take to be wasted? I mean, it can get wasted in a day, but if you spend it on a knowledge, then that knowledge will benefit you for future generation. All right, that's how it works, guys. All right, so guys, as for now, thank you for watching, and then bye and see you in the next video. Please bye and peace.